Hey, how's it going, everyone? Welcome on in. Happy Monday. We are going to be using Rust and the Torch library, libtorch. Thank you to Neva for saying this is the direction you really want to go. And I said, is it though? And it turns out it was. It was the right choice. Now we're going to finish off where we left yesterday, where we defined a simple MLP. We're going to finish the XOR test toy data set. And I'm going to make sure that this model works by the end of the stream. I'm pretty sure we'll get that far. And then once we get far enough down that path and we're satisfied, we're going to then go all the way to the hard part and build a transformer, right? ChatGPT. We're going to be building that. That's the plan for today. I'm actually pretty excited. So where are we here? Let's cargo run. Okay. We're looking good. So we need to create an optimizer. Let's see, we need to train the data, train the model. So we've got our feature labels. We learned a little bit about what this was. So this is a var store that holds all the pointer references to the data. This is where the data is living, the numbers, right? The floating point numbers that are assigned to the model. Hey, Proud by Core, good to see you. Welcome on in. Happy Monday. Hey, Quick Fix, good to see you as well. Good to have you here. Welcome on in. You got my running, Doom is running? You got your running Doom. Oh, operating system, all right. You got it, it's running, good to hear. So we need to get a optimizer. So let's see, what optimizer should we get? Maybe just a standard stochastic gradient descent. Let's see, we need, where would that live? Is that Torch NN optimizer? So this is our optimizer, okay. Let's see if we can figure this out. So let me close all these windows here. So many windows. All right. Let's see. Torch, Rust, compiling your operating system. Hey, there we go. Okay. Build it. Are you building Arc? What are you doing? What are you building? All right. Torch, Rust, TCH. Okay. All right. We need the docs. We're documentation. Here we go. And I need to see where is the optimizer. SGD. Where's SGD at? Here we go. Here's some SGD right there. Okay. Kubuntu. Oh, Kubuntu based. All right. Hey, Bonzupi, your touchpad from yesterday still ain't working, y'all. Oh no, that's terrible. You need the touchpad on your laptop. You need the touchpad. All right, so struct SGD, where are we? So this is in Torch NN. So we need to create a new SGD. So let's try this out. So we're gonna say let optimizer equals TCH NN and SGD, like that. And it's gonna want some parameters, right? It'll want some parameters. Oh wait, what? It's, all right, there we go. Hey Torva, good to see you, welcome on in. Wisdom, if everyone goes in your way, you are in the wrong lane. Oh, hey, how's it going there, Kaga? Good to see you. Welcome on in. All right. Get the next song going there. Kind of stuck in Google. Hey, size script. Hey, how's it going? Google Cloud navigation through these payments and stuff. Oh, you're stuck. Wait, how can you get stuck there? That seems like a place that you would get stuck. Oh, wait, no, this is what I wanted. I did want this. Although I'm kind of curious to see what happens if I run that. It's going to want, all right, some floats. All right, I can do that. It's going to want a few items. It's going to want our VStore, I bet. I thought it was going to want our VStore, right? Momentum dampening WD. Or what is that? What is that? You know what? What we could do is we could also go back over here. Give away memberships. Oh, memberships. Yeah. Hey, that'll happen. Do we have any? I don't know if we have any here. Let's check. Money button, gifting. Let's see. I don't. Okay. Yeah, I don't see. I don't have any free ones right now, but I will give out more later. When they come back in. All right, you guys, let's get back to coding. Where is my... How do we get out of this? Here we go. Okay, 1 second. We're going to get into coding here real quick. I want this... There we go. Okay. My screen was... There we go. Perfect. Okay. Perfect. Hey, Bonsupi, good to see you. It's not allowing access to your previous billing account. Any advice? I do not know. I really don't. I have no idea. I want to help you. I do. I want to help. Where is this? I want my optimizer. And so they're doing Atom. All right, Atom default. Okay. So let's do this. SGD. We'll do SGD. And we'll say like this. : default. Like that. Dot build. And vstore. See, I knew we needed the vstore. I knew we needed the vector store. One. Oh, wait, where are we? Negative. Yeah, so E -3. Okay. So let's see if that works. Happy? Hey, we're happy. All right, looking good. Hadar, good to see you. Welcome on in. Happy Monday. We're gonna be coding. We're gonna be coding our XOR op. And we are going to make sure that it works. And then once we get that and we're comfortable with using libtorch in Rust, we're going to start building the transformer, which is going to take a little while. We're not going to get it done all in one day for sure. Oh, that's okay. What are we building today? We are building a XOR operator represented in PyTorch, well, in Rust. In Rust using libtorch, which is probably the most prevalent AI framework ever. It's the most popular one. Best of 2026. That's the niche. Oh yeah. All right. So the NVIDIA LLM bot succeeded this time. Gone further than it has before. Make it further. Yeah, we're gonna find out. We don't know. We don't know. So we got our optimizer. Now I want my loss. How did they do loss here? What did they do? Loss, cross entropy, forward, cross entropy. So I need to do not cross entropy with logits. I need to do binary cross entropy. That's what I need. Binary cross entropy right here. So this is my optimizer up here. Let me just get this into, here we go. Optimizer. And then we need to do a single pass. We're gonna have to do like a to do for loop for epoch. Sergio, good to see you. Welcome on in. Happy Monday. Whoops, I pressed that right button here. All right, so let's keep going. We're going to be, see, yeah, epochs right there. We're gonna do some epochs. Let me see here. So let's do this. You know what? We'll sort of get this ready. For epoch in 1.50, we'll do 50 epochs. Get that ready. Okay. Oh, let's see here. Okay. Cross entropy, training labels. What is M? Oh, okay. That's right. Okay. So we've got our var store. I'm running the var store on our hardware accelerator, which is my device right here. MPS, right? This is our GPU accelerator right here. Okay. And I want to get my loss. Let's see if I can get my loss going. The thing is, I'm pretty sure this is a problem. So can I do criterion? Can we do something like this? Criterion. Can we do, is there a way to do this? Binary cross? Let me search. Is there a similar option? Let's do binary cross entropy right here. Oh, it's only in the tensor. There's no other choice. you have no choice whatsoever. All right. Binaries cross entropy. Here we go. This right here. Target weight reduction and probably mean. We'll probably do like an average and mean. Something like that. Yeah, mean right here, mean. Reduction, mean. Okay, perfect. You're studying information technology engineering at college. Do you suggest drop it, or the idea very talented in self-learning, but I hate the formal study? Oh yeah, I know the formal study, right? Well, you know what? With formal study, you get some things that you might not normally would get if you were doing self-study, though you do learn more if you're self-studying. So it's kind of got to do both. You got to do both of them, right? Both. Or you don't need the college one. You don't. Like if you could drop one, do the one that's more optimal, then your self-teaching is going to get you a lot further. You're going to get a lot further. I want to do criterion. I wanted to. Can I do, let's see, criterion, something like binary cross entropy. See, I want to do something like this. Let's see. I wonder if this is possible. I don't need it, but possible in TCH Rust. Let's see. It's gonna say no. What? No, wait. I mean, obviously we can do BCE in Rust, but is there such a thing? Is there a binary cross entropy? Or is this hallucinations? Do you guys know? Bar store, predictions, targets, loss. No, all right. Okay. You can do none? None is gonna give you default. All right, that's good to know. Loss, binary cross entropy. So wait. Let loss. Why are there two? Oh, these are two options. Got it. BCE with logits, binary cross entropy. Let's do this. Assumes predictions are already between 0 and 1. Yes, that's exactly what I want. Okay. Alien language. Yeah, we're building it. We're building it right now. So we can't do this, even though the AI said, yeah, you perfectly can do this. No, apparently you can't. So we're not going to do that. We will do this though. So we're going to output our target, none, and then kind is float. All right. I assume we're going to figure this out. Here we go. Let's try it. All right. Then it's going to want labels. Wait. Well, we already have the output though. Weight. What is weight? And then reduction. What is weight? Do you guys know what the weight is? I mean, it doesn't make any sense to me. All right. So let's just say none. None. Can we do that? Is that probably going to be a problem? Yeah, it doesn't want that. It wants something different. Expected reduction found option. All right, let's do, so it is in, where is this at? Torch, just torch reduction? Is that all that is torch reduction? And it won't let me do a default? All right, TCH reduction, mean. Did I do that right? Requires this boundary cross entropy type. Well, all right. Let me see here. Self-target weight. What is weight? And then reduction, I got the reduction. Like I did that one. It's right here. Uh-oh. Okay. It's, the docs are unhappy. All right, good. Okay. Here we go. Okay, I want to figure what does it actually want here? Type information. Okay. We'll figure this out in a few seconds. Cannot infer type of parameter T, must be of known type. So is it want a kind? Is that what that wants? It wants kind? So TCH, did I already have this? TCH kind float? Something like that? So can, oh, wait, why does it, why? Really? No, that can't be right. See, I told you. Sometimes, here's the deal. When you're working with Rust and the compiler, it's going to give you suggestions. You're going to say, okay, I'll take that suggestion. And it will be it won't work. It just won't work. Not implement. So let's see if I can get a better, I need to see how to use the system. Let's see. Oh, so I did the forward, right? So I got the output. What if we tried this? What if we just did, let's not print this. What if we only did the loss? So we did net forward features, binary cross entropy out. There. Is that gonna work? Because that's like what the tutorial looked like. It still wants all the other things. Okay. So it doesn't matter. Okay, it doesn't matter. All right. That's fine. We don't need to worry about that. Out dot. There we go. You're learning Python programming. Hey, skeptical. That's a really good, I love Python. I do. Right now we're using Rust. We're using Rust to get this working. Once I understand how this works and I get our XOR model working, we will be successful at starting to build a transformer in Rust. Yeah, that's gonna be a good one. We're gonna build a transformer. Okay. Cross entry. See, this is exactly what I want. I want this syntax right here, but it's not letting me. Let's see, lost net forward train images. All right, good start because of simplicity. Yeah, I think so too. I agree. Quick fix. Simplicity is a really good place to get started. All right, so I need here. We're going to ask the AI for help. Gemini. All right, this is giving us an error. Paste. All right. You know what? I'm just going to put none here so it's a little bit easier to see. So that way. Type. It still wants type, but you know what? Type must be. It already knows the type. It's inferred. It's right here. The type is right there. Machine learning roadmap, TensorFlow library. Ooh, yeah, TensorFlow and Keras. Those are good starts. Do TensorFlow and Keras. I like those. Let's see here. Must be known at this point. Cannot infer type of the parameter to declare. See, you know what? That's fine. That's fine. I would love to get an example of how to use this. All right. How to use TCH Rust. Test today. Gotta go. All right, Rox, that sounds good. Good to have you here for a little bit. Oh, I killed Gemini. Look, it didn't work. It gave up. It doesn't even know. It didn't even know. Cannot load the chat. It got deleted. All right. Let's try Gemini, see if we get it again. It doesn't do it. Look, it gave up. It's giving up. Oh no, okay, fine. It just took a while. Show an example. Target option tensor. Oh, of course, it's gonna be a tensor. What else would it be? Wait. Hold on. Also, I just want to see an example of it. Okay. Reduction. See, this is what I did before. I don't want to use logits. Targets. Slice to device. I don't want to use logits, though. I mean, I could. Please don't forget to blink your eyes. I know, skeptical. I know. I'm like, what are we doing here? BCE, I'm just trying to do some we could. So it really wants us to use not. See, I already did this part though. Probabilities, logs, sigmoid. Interesting. Okay. All right. Well, we'll try it. We'll see how it goes. Here we go. None. See if that works. It's gonna want logits. Okay. So we will try the other function with logits. And is this technically? Yeah, it's technically logits. It's technically logits. Is that better? No, it's still giving me the same error. Hey, the Forts, good to see you. Welcome on in. Happy Monday. You make content on coding? Yep, that's what we're doing right now. We're going to be coding furiously until 9:30 a.m., which then I have a meeting to go to. So don't worry, we've got an hour and 10 minutes. We got plenty of time. This does not. Oh, wait, right here. So this isn't working at all. See, is that right? Yeah, see, I've got it correctly. So logits, the output. Yep, we got them right there. This is going to give us the targets, which I called mine labels, right? I just call them labels. None, and then TCH reduction. It's reduction. Yep, TCH reduction. What if we just included this here? What if we did this? No. Reduction. There we go. Okay, better now, maybe. Ooh. It's different. Not found in this scope. Binary cost entropy. Where did I? Oh, whoops. Here we go. Okay. All right. Oh, what? Are you kidding me? Really? Okay, so now I've got a different error. You cannot infer the type parameter t declared in the method binary. What? You can already infer it because you've got it here. It's right there. It's in your face. It's in your face. You can infer it. It's inferable. Okay. AI and Rust programming. Hey, that genius. Hey, the skeptical. Yeah, this is. I'm gonna very much enjoy this once I've nailed it down. So this morning we're gonna struggle through it until we figure it out. And right now we've got some issues. So what I'm gonna do is I'm gonna open up the cheat. Hey, Brandon, good to see you. Welcome on in. Happy Monday. So I want this right here is gonna copy the burr. Let's copy this over here. And then we'll paste in the error. Our error is right here. Let's copy this. It's nothing on the internet is giving me the information that I need in order to be successful at writing this. So we're going to do a little bit of cheating. I know we don't normally do that, but we're doing a little cheating. Yo, Steven, good to see ya. Welcome on in. Happy Monday. All right, let's see what we got here. Let's cheat just a smidgen. I just want a little bit of cheat. We're going to type it all by hand. Don't worry. Hey, Vicky. Thank you for subscribing. Welcome on in. You joined the right channel for software engineering. We are building some AI in Rust is what we're doing. That's the plan for the next few weeks. Avanish, good to see you. Welcome on in. Happy Monday. Good to have you here. Okay. Are we going to get any answers or is it going to spin? We'll keep trying on our own. We'll keep trying. So type, blah, 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 type, do we have to say type is going to be something like this? Does this have something we have to do? Remember your first shared canvas? Yeah, it's not working. Can you make it work? It definitely should be working. I don't have it up anymore though. Can you, if you paste a link to it, paste a link. It should definitely be working. You can see passionate about it. Yeah, I subscribed. Skeptical, thank you. Quick fix, good to see you. Even for a short period. All right, so this is going to be and tensor. Is that what it wants? No way. No way. No way. Really? Are you kidding me? That was all I needed right there this whole time? What? Are you kidding me? There's no way. All right, let's just do regular binary cross entropy with tensor. So we figured it out. We figured it out without the help of AI. Look at that right there, you guys. Oh my goodness. Hey, look at where I feel so special right now. I feel so special. Look, it's real. It's real. Oh, that's what I'm looking for right there. Okay. Let's do binaries copy. Let's see. Hold on one second. Let's bring this back really quick. Like right here. Okay. And then yep, okay. Let's see here. No, I want to get rid of those. Okay, thank you. Okay. That is interesting. Okay. All right, there we go. It just took a little bit of extra push with whatever this was. It should have been obvious. Of course it's going to be a tensor. Of course it's going to be a tensor. What if we did this? Tensor. Like that. Can we go the opposite direction? So it's a little bit easier to read. Ampersand. It's gonna be the address of a tensor. No. Okay. I'd much rather label it with the data type that it needs. Right here, as opposed to over here. But whatever. Tensor 1D matrix. Yep, tensor 1D matrix. That's a vector, right? It's a vector. What's up? What's up? Hey, how's it going there? Jaden, good to see ya. Welcome on in. Happy Monday. Cardum Erdem, good to see you as well. Okay, you're saying, all right, sounds good. Quick fix. 404 GitHub pages. It should still, I didn't get rid of it. It should still be there. You're probably just hitting the wrong URL. J10. Yes, J10. Oh, it might my subtitles might look like I said Jaden, but I said J10, right? J10. J10. Hey, that Vasper, good to see ya. Yes, 10. Okay. Jotin. Okay, Jotin. There we go. Much better. Tensor time. Yep, we got ourselves our tensors. So that's, we got our output. Now we've got our loss. We got our criterion. Now we have got our optimizer. Let's do a loss.backward. Can we do that? Is that something we can do? Will it let us do it? It will let us do it. All right. Optimizer. Wait, how does the optimizer know what the parameters are though? Oh, because it's got the v store. Okay, it's got the v store. So we could say optimizer dot step, right? Optimizer dot step. Is that gonna do it? Exception. What? No, wait. All right, hold on. Okay. How come less people on such an awesome stream? I don't know. We're gonna do it right now. Thank you. Thank you for saying that, J10. I appreciate it. Brother, you got me dying. And learning AI where I can do it. Yep, we're doing it through the docs right now is where we're doing it. Okay, so where is my optimizer here? Backward step. Okay, we'll try backward step. So wait, but we already have lost that backward there. Loss forward, opt backward step and loss. Okay, let's try it. So this is a little bit different. Quick fix. Oh, hey, quick fix. Hey, Loons, good to see you. Welcome on in. Just got to learn Rust. You're not gonna chat a lot. Sounds good. Loons, good to have you here. All right, here we go. 1 second, you guys. We're gonna keep typing 1 second. There we go. Okay. So it said backward step, like that. So we do it differently, and we say ampersand loss. All right, let's see if that works. It didn't like that either. It also wants an exception, but the code doesn't have that here. In the demo, it doesn't have that. Do you recognize all channel videos in playlists yet? Organize. Oh, no, I didn't. It's not, I'm not gonna, I can't do all of them. There's too many. There's too many. I did a lot of them though. You can see we did quite a few, right? Steven on YouTube. Here we go. Playlists. Yep. So we did quite a few. Not all of them though. Hey, quick fix. It might have already happened. It might have already happened. Okay. You are. That's it. It happened. All right. So, let me look for other options of backwards. Backward. So they always do it through backward step ampersand loss on the optimizer. There's the reason right there. Okay. We figured it out. Unwrap. Also, we should not unwrap. Of course, it's not hygienic to do that. I know, we're gonna do it right now though. We're gonna do it right now. Yeah, that's fine. It is fine. Let's see, why does it say, I typed it wrong. It's gonna be unwrap. Here we go. Optimizer cannot borrow as mutable. Do we need to define it differently? Oh, it has to be. Okay. Let mute. Here we go. Hey, there we go. That's what I'm looking for. Kyle, good to see you. Welcome on in. Happy Monday. All right. You want to abuse it? Sounds good. New mod, say hello. Steven still counter on the shared canvas is messed up. It says 1,000 people. Oh. Okay, got it. We'll have to fix that later. Let's see. We are heavily focused on our AI right now. All right. So why is this commented out? It's the same thing. All right, let's get rid of that. Now let's see if we can optimize this and make it work. Okay. So we should do a for loop. For epoch in 1.50. See if that works. We'll throw this in here. Here we go. Okay. Happy Monday. Whoa!
Happy Monday. My only TTS today, lol.
Kyle, thank you. I appreciate it. My gratitudes, Kyle. At Flip Profit, you guys. Flip Profit. Flip Profit. Flip with Kyle. Thank you, Party Popper. Here we go. All right. Paste. Thank you, Kyle. Appreciate it. That's really nice for you to do. You went overboard yesterday. Hey, it was good. I saw you. You did. You did good. That was amazing. Thank you. All right, let's see if I got my for loop looking gear. For loop looks good. Yep, that should be fine to me. All right, let's try it. Boom, right there. All right, so let's print out less. So we don't need the output right there. Let's print out just the loss. That looks good. Is it dropping? It is. It is dropping. All right, so let's do 5,000. All right, here we go. Yeah, look at that right there. That's what I like to see. All right, this is great. We now have the power of Rust and AI at our hands right here. We can do this on our keyboard. 900 XP. Yeah, that was a lot of XP. All right. I would like to print just the float. Can I get like the item? Can I do this item like that? Just like in regular PyTorch, can we do that? Print L in explanation point. This. Can that work? The iter. No, I want item, not iter. I want item. I want the item. How do we get tensor to, see how to do this. Let's go back over here real quick. I'm gonna say Google, I wanna say torch, tch, rust, tensor to rust, let's say like a float. How do we do that? Yes, tensor double value, int value. Oh, okay. Why this though? Why that right there? Double value. What's this right here? Why? Why is it doing that? That's crazy. Steven, I made a 2-file folder explaining Python core system for people starting to learn Python. Shall I put in Discord? Yes, absolutely. Absolutely, do it. 950, whoa. Okay, let's try this, you guys. So we're gonna say let item equals loss. This would be item called 64, F64. Loss dot, was it called double value? Okay, double value, which is weird. And then for whatever reason, we're gonna do ampersand. All right, now let's just print this out as normal item. See if that works. Whoop. All right, run. Okay, here we go. Yeah, that's right there. Okay, sounds good to me. YouTube broken kept it giving me XP. They did. They give you a lot. You gave a lot XP. All right, so now I'm happy with this. So what I'd like to do is do one more forward. Let's do some tests here. All right, so this is training. This is training epochs, and now we're going to be doing some accuracy testing. Let's do this. Yeah, this is great. I love it. I love it. We'll do just one. Let's do one. And they'll say out.print. Like that. That's it. Boom. Easy. Done. Okay. Got a question. What does the explanation do in Rust? It is a macro, and it's at compile time. So 100% of the code essentially is built in the application at compile time rather than runtime. As far as I know, right? That does not look correct on the output. That looks very wrong. What did we do? Wait. We did it. It should. Is it gonna work? Is it gonna work? -2. Oh, you know what? Because we're doing tan H, and we're optimizing. This is weird. Hold on. So this is actually correct. So if I should say above 0 and below 0 is the answer. Although, let's see if we can do without the logits. Let's see if this does anything different here. Let's try that again. Okay. 100. Well, that's not going to return. That definitely is incorrect. All right, we'll bring that back. Okay. Tell them someone Roblox told me to do it. And someone in Roblox, exactly. Books read, take on test computer. Take the test on the computer. So this is correct. It's giving me the exact answer I want to. So What are ways to how do we do like a rounding? How do we do rounding in Torch? So let's see. Rust TCH round tensor. How do we round the tensor? So we can get round to the nearest. Yeah. Round. All right, fine. How do we do? I suppose we could do an activation on the output to target between 0 and 1. So let's do an activation on output. We will do a sigmoid. Here we do. Sigmoid. Let's try that. Okay, now it should be correct. And we do round. Oh, wait. Oh, that looks... No. Nope, that's not good. It's almost right. It's almost right. Maybe we need more training steps. Yeah, I don't like that. I don't like that. All right. Let's bring this to tan H. So that way the linear projection can only between -1 and +1. Yes. Okay. I like that a lot better. Okay, perfect. Perfect. We're in a hurry, or do we have time today? That Vasper question, what does it do? Oh, we've got an hour, so we've got time. We're not necessarily in a hurry, but we do have a time limit. Subathon, oh, I know what you're saying there, yep. Stream all day and all night, well, I don't know, not quite yet. Not quite yet, Kyle, maybe someday. Okay, so we don't need this, we did that, took care of that. Now I want to, can you do it round? We do something like that. Looking good to me. Yep, all right, there we go. There we go. This is correct. This is the correct answer. That's correct. Right there, we did it. We did it. Why cannot see flip with Kyle message? Oh. I don't know. I don't know. JK, I don't know. I don't know either. I don't know either. Okay, we did it. We succeeded. We succeeded. Okay, so what we need to do next is we need to start, I guess, building our transformer already. Are we ready to do it? There's a lot of work to do there. There's a lot of work. Okay, let's see if we can make it work. Okay, so let's close this. Let's get rid of this. Did it? Oh, so it did. It did what we wanted to do, except for saying not ampersand. So can I do this without ampersand then? Is that going to work, or is that going to fail? It does it either way or not. Okay. So I guess we're learning more. The more we know. The more we know. Okay. So we learned a little bit there. Perfect. Okay. So I'm happy with this. This looks good to me. What I want to do next is... Let me get rid of this here. Escape, go away. Thank you. Let's get rid of everything. Oh, I would... Okay. Here we go. How do I want to do this? Is that going to... Okay, that's what I thought. That's what I thought. Okay. Deactivate. All right, so cargo init transformer. Transformer. Although... Is this what we want to call this? Let's call this, yeah, let's call this like Rust Transformer. Okay, I think it's better. CD Rust Transformer. Cargo add TCH. Before I do that though, let's do activate source vn bin activate. Then I want to do a tmux, and we have to do this again here. Oops, I'm not in tmux yet. Here we go. Okay. Deactivate. Deactivate. Yes, thank you. Activate again. Okay. Hey, Derek, good to see you. Welcome on in. Good luck, givers, takers. Good to see you as well. Good to have you here. Lions for Lambs. Hey, everybody's here. Early lunch. Yes, early lunch today. Dinner time. Bye, guys. All right. Thank you so much for subscribing. Appreciate it. Okay, so where are we here? Let's see. Cargo build. BUILD. Okay. And then we're going to say, did we add this to the cargo? By cargo toml. We didn't yet. Okay. Cargo add TCH. Okay. Cargo build. Make sure we're up to speed. Hey, Mark Lemon, good morning, brother. Good to see you. Happy Monday. All right, Brandon, thank you for saying hello. Good to have you here. VMs is a feature also in Rust. Oh, it is. The thing is, since I'm using libtorch, we're using the built, we've installed it through pip. So we pipped installed it. So in order for Rust to get access to it, watch this, VM bin activate. I had to put these extra lines of code here at the bottom of the file. Set wrap. So you can see I had to add this in. So that way we can load in the libraries. So that way we get libtorch through pip. So I had to do it this way. This is like one of the annoying things that you got to do. It is. If you use other AI libraries in Rust, it basically comes with everything you need, which is very nice. However, libtorch is way nicer to use. It's a lot nicer to use. So we are using libtorch and we're saying goodbye to burn library. Goodbye to burn. By source. Here we go. Main. Okay. So, I want to start by, we need to do a lot of things. There's a lot of things that we got to do here. We need a tokenizer. We're going to try to use the built-in tokenizer. We need to load data. And we're going to capture some data. Where should we grab this? I think we should close it out here. Okay, I want mkdir data, CP, the copy, desktop, what was it called? What did we call this? You remember? Was it PyTorch? Was it Transformer? Transformer PyTorch, here we go. And we have something called, I suppose, this is right here. This is training.py, okay. PyTorch training py, and we're going to just say this training.py, data training.py. There we go. Looks like burned you, my friend. It did, Vasper, did. You got it. Yeah, libtorch, way better. Way better. Okay. Happy with this now. So I've got my data. I've got my training data. Maybe we can grab some more. There's more to it. There's more to it here. There's also the file itself, which is going to be the transformer.py data / here we go. Okay. Hey, Ruchik, good to see ya. Welcome on in. Happy Monday. Everyone else, how was your day? We're doing good. We're doing good today. Happy Monday. Week started off to a good start. Let's see. Was there other things that I wanted in here? What else did I want? Golf. I want golf. Okay. So I want to say cat golf to the training. And then we're going to cat the transformer in the training. Then we're going to remove the, what is it called? Transformer and the golf. Yeah, perfect. Now we've got training data. 204 kilobytes worth of training data. Perfect. Okay. It was great. Thank you. Excellent. Okay. How's it going there, Ashad? Good to see you. Welcome on in. Happy Monday. All right, so let's open up our data now. Oh, I also should do something like this here. Deactivate source virtual environment bin activate. Okay, get status. Oh wait, there's already. Oh, no way! Cargo automatically initializes a Git repository for you. Hey, that's great. And it also gives you a Git ignore file. Look at that. And it excludes target, so you don't include all your build objects. That's awesome. It's been a while. I didn't know. I didn't know they did that. Okay, git commit empty. So what we're going to do is we're going to be building a transformer. Yeah, we're going to build ChatGPT in Rust with libtorch. 45K increment was about to lose. Only one account got saved. Game left, you know. Only about one account can save you. What does that mean? I don't know what that means. Can you do a series on teaching Rust, please? Yeah, we did. We can do it again. We've got the rest of our lives, right, to do it. We do. So look this. You probably already know this, right? So if you don't, we're gonna find it right. It's called Rust by Example. You type that in and go to videos, and there is that rec. Do you recognize that person right there? Hey, look who it says. It's me, right? Stephen Blum. Right there. Oh, hey, the next one's also Stephen Blum. I had the other way. There we go. A whole series of Rust by Example. It's my favorite way to learn any programming language is by example. Empty transformer. We can do more though. We can do more of those. Git commit empty transformer. All right, now let's create a repo so we have all this. All right, so GitHub. Here we go. Create a new repository. Dog Steven. Hey, we're back. Happy Monday, bro. Thank you so much. Good to have you here. Happy Monday. All right, new repository. Call myself. All right, so this is going to be Rust Transformer. This will be public. Create. All right, now we're going to push it. Push it to the limit. Here we go. 45,000 Indian rupees was stuck in one account. Oh, if you know, you know. That importance of password. Oh, no. If you have any funds stuck anywhere, that is awful. That would be terrible. Okay. Build. Run. Looks good to me. Okay. So, what is called? Use TCH. Looks good to me. Okay. Use TCH call. All right, let's do reduction. Right, we got some Russian. I would also like kind. Let's see. Can we do? What else do we want to do here? Let's look at what we did previously. First torch Rust. The source main. Here we go. Module. Yeah, that would be good. Module. I like that. That's a good idea. Let's see here. So let's do module. So how about this? Anything that we don't want here. So device and reduction is kind. Where's kind at? You know, we haven't been using kind, so I'm not going to bother with it. So we'll do NN like this. We'll do module. I like that. That makes me happy. Then we'll do optimizer. We never used optimizer config. What would we can even delete this here. We've never used it. So we see NN module. So device and reduction are not under NN. Only module is. Okay. Okay, only module. So then what we can do is put that there. We do reduction and device. Because we do use device. All right, perfect. And then of course tensor. Of course tensor. Tensor. There we go. Perfect. Hey, Diffashan. Good to see you. Hi, man. You're a genius. Well, thank you. Appreciate it. Good to have you here. Happy Monday. That's very nice for you to say. Hi, man. You're a genius. Well, what a wonderful compliment, right? You're scared of the Microsoft Jaws? Yeah. Mm-hmm. Micro slop. The chat on mobile is a little hidden and camouflaged because of the terminal. Oh, yeah. Mm-hmm. I can see that. Yep. I see that. Okay. Let's keep on going. So we can get rid of this. We're going to create our network. Although we need to do a lot of things. All right, so let's label everything out here. Let's put everything out. Everything that we need to do here. All right, let's list them out. To do. We'll do all the to-dos here. There's a lot of things. All right, so we need to do tokenizer. We need to do attention algorithm. Let's say attention algo. We need to do the model network, which is going to be a lot of different things. We need our embedding. So we're going to put this up here. So tokenizer, embedding, and then our projections, model network. So projections. That's what we got to do. That's why you use Linux. There you go. Linux distros right now, Android and Kubuntu. Those are good ones. Android counts. If you didn't know, Android, it counts. It counts. Okay. All right, I think that's a good start. So let's get our tokenizer. And then we need to load a file. All right, so let's load data. Load data, and then we need to batch and shuffle. Tokenizer, intention, algro. Okay, batch and shuffle. What else do we need to do? Let's go back to our diagram previously to see if I missed anything. Here we go. Okay, so tokenizer, embedding. Oh, positional encodings. Right. Embedding, positional encodings. Then we did projections. We do QKV softmax. Oh, multi-headed attention, right? So attention, multi-headed, which is easy. I understand. I basically understand that. So basically, you have to reshape twice, 2x. That's what you got to do. Got to reshape 2x. Okay. Required by law to say use Arch, by the way. You do. You got, yep. Arch BDW. Then we do our feed forward. All right. So we do our feed forward, which is just an MLP. And then, oh, we got to do a lot of norming. All right, I forgot about this part. All right, so we have to norm constantly. I got to norm a layer. Needs 3x layer norms. 3x layer norms. LE. There we go. Layer norms. A lot of norms. And then that's it. And then output projection. And then we can do multiple blocks. Okay, multi-block. So we're going to have a transformer head and our transformer block. And the head will wrap everything, right? It wraps it all together. All right, transformer head and block. BLOCK. There we go. Okay, so let me just kind of move this around here. Copy that. Bring this back up to the top. Okay, where should we put this? I mean, we should get started around here, maybe? Okay. Model network projections. We're good there. Attention algorithm, multi-headed attention. Feed forward, and there. This will give us the transformer. There we go. We're right there. That'll give us a transformer, you guys. This is going to be quite a bit. It's going to be quite a bit. So we can say function, we're going to call this the, how do we want to do this? Where's our forward occurring here? It's occurring down in here. So I wonder if there's a different way to represent modules in Torch on Rust. If you guys know, we're gonna find out. Did we push this? Yes, okay, we did. Okay. Looks good to me. Okay. All right, are there different approaches? So this is like the main approach that we've used so far. We've created a simple network. Are there other approaches? Let's find out. Let's find out here, you guys. Oh, we got softmax, of course. I like how you're doing it section by section. Yeah, by the sections. Yep. So we've got a roadmap ahead. We know everything that we need to do here. And we need to figure out how we want to represent it. Are there different approaches? Let's see. Result empty. I suppose we could do this. Arrow results. Empty results. Okay. Only have one result as an option. You just say okay. Like that. Here we go. Let's make sure that this still builds. I'm pretty sure it will. It's going to... Oh, it wants the error. Wait, really? Do we need like an anyhow? We do. Use... It's called anyhow result. Anyhow result. It's going to give us a little bit better. Did it not... Did I type that wrong? Anyhow result. anyhow result. I think I need to add this. All right. So we'll say cargo add anyhow. There we go. Vi cargo tunnel. All right, dumb, easy. All right, good. Now, run. There we go. Okay. 2 dependencies. What a good project. I'm liking this. Okay. Yep, success. Okay. A lot of warnings. We don't need to worry about that. Sup, guys? How's it going? Oxnell, good to see you. Happy Sunday. I mean, Monday. I was thinking it was still the weekend. It's not quite. We made it through the weekend. We're done. We finished with the weekend. It's Monday now. I know. I want it. It lets you know what I want it to still be. I want it to be the weekend. The weekend is great, you guys. Okay. So we got everything set up nice and looking good. My question is, are there other examples that we can use here? Let's see. Is there multinomial? All right. So I don't see any examples here. Further examples, char, RNN. All right, so let's take a look at this really quick. See if there's any other approaches. Or the only text data, LSTM, linear, all right, sample. The weekend here is Friday and Saturday. Oh, by the way, that's right. Friday and Saturday of the weekend. Sunday is the beginning of the week. The beginning of the week, you guys. Hey, see, multinomial. I told you, multinomial. All right. Back, forward. Okay. Soft max, multinomial, squeeze dimensions. Okay, yep, I understand. Tensor zeros. Ooh, see, this is what I like right here. I like that. Kind float device. Okay. So this line of code right here makes me very happy. I like that a lot. Now, where's the forwards at? I want to see where all the forwards are at. Epoch batch. There is a one hot here. Interesting. Okay. Backstep clip. Includes a clip? What? No way. Look at that right there. Okay. That's good to know. It used to be Thursday, Friday. 10 years ago, they changed it to Friday and Saturday. Okay. So let's see. Sample. Data LSTM. All right. So where's our LSTM? LSTM's defined up here. Root labels, hidden size, and our labels is gonna throw in the actual labels here? This is weird. That's very weird. You've got your linear, okay. Optimizer. I like this. Okay, this is a good reference. I like this right here. I like this reference. It's a pretty good reference right here. Okay. So let's go ahead and get things going. So we'll say let device equals, was it device : MPS? Right? Will that work? Because it's there we go. Looks good. Waiting to hear back if I got a new job or not. Oh, Kyle! Ooh, hope you got it. Yeah, I hope you got it. What else do we want? We need our var store equals. Did we import this? We didn't. All right. So what is this at? It is a neural net var store. Okay. We'll just say var store. Okay. Var store. Okay. Var store. New device. Make sure it works. All right, look, we got an error already. Already an error. No var store. Oh, we got to do in. Okay. Okay. Every single line of code, it's really good to always build because you run into errors otherwise, and then they stack up really quick. So build all the time. Oh, ooh, look at that right there. Ooh, I like, okay, nah, all right. Thank you. Let data equals, all right, text data. What does our text data look like here? Where is that at? It will be data, torch text data, okay. TCH data, text data. And then we give it a path, which is going to be data/training.py. And we say question mark. I didn't like it. Torch data, text data, expected function, tuple structure. Oh, data. What happened? All right, data training.py. Try that again. Okay. Let's see. Expected tuple. Wait, what? Why? Why? Why is it expected tuple? Text data new. All right. Let's do this. Text data. Use. I suppose what we could do is we could just say this, like this. And then we can start. Do we use TCH anywhere? Only here. Okay. So let's make this prettier. Also, let's get rid of this window over here. Okay. All right, let's make this easier to read. All right, now we've got everything. Easy to read, easy to read. Looks good to me. Okay. All right, so now we're good to go. Did we do it properly? Is this correct? Text data new question mark. Yeah, right there. Data. It's data right there. It should be fine. Your hammer had been a few weeks working with a client whose headquarters far from your area, 2 hours away. Have fun, guys. Gotta sleep. All right, sounds good, Axel. Thank you for stopping on. Good to have you here. Could not compile. Expected function tuple struct or tuple variant found struct money data. Is that a problem? I mean, I thought this was going to be exactly what I wanted, but apparently it's not doing anything I want. Text data. Let's see here. Let's see. Yeah. So we'll try using it like this, I assume. Let's see if this works. We get rid of this. Is that going to be better? No, it's the exact same thing. Exact same thing. Okay. These little teeny things, these little teeny problems that you run into, you guys. Little small problems that you run into. Data text input.txt. Does it want a different file? Is it unhappy? mv data training.txt. I highly doubt it. This would be really annoying. It's just text data. Should be fine. Yeah, see, that's what I thought. Okay, so that didn't make any difference. Text data training, it's right there. It's, right, I assume. All right, let's see if we can get some assistance really quick. All right, copy this. See, deactivate source /VM bin activate. Okay. All right, we're gonna ask the AI for help, you guys. This seems to be a really good option to do. Okay, let's click that button. Let's see what it comes back with. Because this should be fine. I'm assuming. I don't know. I assume it should be fine. Let's see if we can fix it before the AI fixes it. I don't know if we can or not though. What if we get rid of the question mark? Expected function tuple struct or tuple variant. Found struct text data. Pub struct text data defined here. Print ln exclamation point data. Let's try that. Nope. Okay.
input.
Fine, read. Okay. Let's see what it comes back with, you guys. It's not, we're not going to edit, we're going to do all this by hand. We just need to get a little bit of help here. No, here we go. Oh, new. Did I not do new? Did I forget new? Is that all it was? It was, oh my gosh, you guys. It's so simple. It was so simple. It was right there. My goodness. My goodness. Hey, how's it going there? YXNGRX. Good to see you. Welcome on back. Happy Monday. Okay. Cannot. Okay, well, fine. We'll do it differently. We'll do it like this. Data. Fine. There you go. All right. We'll say colon question mark. Print it. That's like the print button. Hey. All right. Look at that. I have no idea why it's printing this, but oh, there we go. All right. Char for label. There we go. Hey, Divyansh. Hey, Divyansh. Good to see you. Hey, Brosk, welcome on in as well. Happy Monday. Good to have you here. All right, let's get our code going, you guys. All right, so we've loaded our data. Now we did data loader. Let's get our tokenizer. What's a good tokenizer? Let's see. TCH Rust tokenizer. Instead of writing our own, let's just use the built-in tokenizer. It might not come with one though. Token. Why did it give me this link here? I need the tokenizer. We must have one. Hey Zabian, good to see you. Hey, no worries, you're all good. TV is the way to do it. Thank you for saying hi. I watch TV. I watch a lot of anime. I'm watching this Sword and Wand. It's really good. Tokenizers. Yes, okay. From file JSON, tokenizer.json. Load the tokenizer config. Okay. Text to tokenize. Encoder. Text tokenizer unwrap. Token IDs. Yeah. Oh. Is there a different option? I want to see what the best tokenizer is. I need a really good easy one. Like a really good easy one. This one seems pretty nice. Okay, yep, and torch. Looks good. Okay. Where are we here? Oh, that might not be what I want. No, I don't want this. Okay. I'm not sure about this. This does not look like what I want. Token. Here we go. Speech. No. Okay. Not that one. Text tokenizer. We can make our own text tokenizer. Okay, where are we at here? All right, a whole bunch of tokenizers. What? Tokenizers. Okay, is there like a crate for this? Add dependencies includes tokenizers. Okay. Crates.io tokenizers. Come on, crates.io. It's a simple string lookup. You can do it. Is there not a tokenizers? All right, how about we do this? Tokenizer crates.io. Wait, crates.io. Here we go. Okay, perfect. The core of tokenizers written in Rust provides an implementation of today's most used tokenizers. All right, let's see what here. Tokenizers, tokenizer. Result, tokenizer. All right. So we just do cargo add. Do cargo add tokenizers. Cargo build. All right. That added a lot of dependencies. That's a little bit annoying. All right. No worries though. No worries. All right. So use tokenizers, tokenizer, and then we say tokenizer. Wait, what was it called? Results? No, we don't want to do that. We do want to say tokenizer though. tokenizer. There we go. Nice. That's what I'm looking for. Perfect. Okay. Let's see how to use it. Let's see. Pre-trained. Oh, interesting. Needs HTTP feature enabled. Is there a different tokenizer? Why don't you like to have a lot of dependencies? Well, typically you want to keep those minimal, right? Because it's going to bloat your application quite a bit. Obviously, the compiler is going to optimize anything out that it can. Though, if you have something with a lot of code, it makes your binary bigger, right? Target, debug, build. Wait, where is our... See, deps build examples incremental. du-h target. There it is. It's this right here, right? Target debug. Is this it's a directory, okay. Yeah, it just makes it bigger. Thanks for saying hi, Zabian. Okay, let's keep going, you guys. Are you writing with Python? Oh, hey, Laredo. Hey, Laredo. All right. We are writing with Rust. We're doing Rust. We're getting our tokenizers out here and ready to go. Byte pair encoding. Yeah, there we go. This is what I want right here. Byte pair encoding. Do I need to include vocab though? Can it byte pair encode on its own without a path to vocab? Unknown token, build, dropout. All right. So I kind of want to use this. New BPE. Okay. Let's see if we can go. Is it programming? Yes, it is. We're building a transformer. So we're in Rust. We're going to write. So we've got a plan here today. We're going to write all of these pieces of code in order to build ChatGPT. We're going to rebuild it, and we're going to build it in Rust this time. We did it in Python. We did it in Python already. Now we're doing it in Rust. I'm really excited about this. So we're going through each of the phases here. Look at all of these things. My goodness. My goodness. Trainer builder. Tokenizer. Hold on. What's this? Training and serialization example. Deserialization and tokenization example. Loading a pre-trained tokenizer. It would be nice if I could just if I could just build one. Because if not, I'm going to build my own. I might just build my own. Vocab size. See, like I don't want to be restricted by that. I want it to be dynamic, you know? Special tokens. Tokenizer. Okay. Where do we want here? I want serialization. Loading a pre-trained tokenizer. No. Deserialization. No. I want serialization. Like really simple. Training and serialization. Okay. This is what I want. However, this is a lot. This is a lot. Okay. Maybe is there like an easier example? Okay. Rust tokenizers. Example. I'm just looking for something clean and easy. Cargo tunnel. All right, so I've got that there. From pre-trained. See, it keeps wanting to bring in from pre-trained, which we might be fine for, I guess, maybe. All right, I mean, let's try it, I guess. I don't know if that's something we can do. Okay, run. I figured as much. Association function constant tokenizer. Oh, did I not import it? I did. It's right here. Associated function are constant, not found in tokenizer. Did I do this wrong? Oh, okay, I did. Tokenizer is tokenizer. Okay. go. Same thing. Same thing. Are you kidding me? This is one of the things, you guys. Okay. Are we getting hallucinate? Maybe, you know what? This Gemini. Hey, quick fix. Oh, welcome back. Good to have you back. All right. Tokenizer. All right. Well, that didn't work. You have to give up after a certain point and try something else. We're gonna build our own. We might just build our own. Okay. Use Android now, by the way. Ooh, me too. I like the Android right there. Okay. So I'm not happy with this. I don't like it. Is there better options here? Tokenizer new. Let's try this. Tokenizer. Here we go. Tokenizer new source code. Oh, it's all... Okay, got it. For iterator. So this is building our own tokenizer. Using... So wait, what's this? Custom Lexer tokenizer. If you are parsing custom language format or math expression, you can write a lightweight tokenizer by matching character boundaries. This code reads an input string and slices it into structured tokens, identifies numbers, mathematical operators. So I like this a little bit better, though this is not exactly how I would build it. I would build mine a little bit more simply. So let's... Maybe we'll build ours a little bit more simply is what we should do. Okay, maybe that's what we'll end up doing here. Okay. Because this is not working. Okay. Cargo time. All right, how much time? All right, we got 10 minutes, you guys. We got 10 minutes. Delete tokenizers. Sir, let's see. I mean, let's just see if there's something else. All right. Easier to use tokenizer for char level tokens. Can you switch to Minecraft music? Oh, sure, quick fix. There you go. You asked for it. You asked for it. You got it. Yeah, here we go. Okay. All right, let me grab this over here. Here we go. All right, so okay. Oh, I heard it. Here we go. Perfect. Okay. So let's do a function tokenizer. And it will return a vec of U32. Okay. We're going to return all the IDs, all the token IDs. So we're going to pass in, so it's going to be text, which is and stir. And then we are going to okay. Let me do, see here, text dot chars collect. I think that's it. Is that it right there? Did I do it? Is that it? No, we have to do some conversions here. All right, so we have to do a little bit of conversion. How about we do this? We do vect of char. Although we don't necessarily want the char. We need the dictionary though, because we're gonna need to decode it later. So we need to decode it later. Hey, Mindfuel Daily, good to see you. Welcome on in. Happy Monday. Okay. So we're gonna build our own tokenizer now, because none of the tokenizers that I saw were what I wanted. So we're gonna build our own now. Let's see. We're gonna text char. So this is an and stir. This is, so let's do this. Tokens. Well, this isn't necessarily, this is chars, really. This is chars. Chars equals vec of chars equals collect. All right, so these are the characters. And then we need to return, convert characters into unique numerical tokens. So this gives us the tokens. Yes, okay. I need a way to do a lookup is what I need. I need to be able to convert, serialize, and deserialize is what I got to do. So I need the dictionary, and then I need to serialize and deserialize. Entrance exam. Oh, today you failed on the med school entrance. No, you prepared for 4 years and you failed. That's too much preparation for 4 years. Okay. Where do we want here? So in order to get our tokenizer to work, we need to build a dictionary, or the vocab, right? Dictionary vocab. We need to build an encoder and a decoder. Right? We got to do those two things. Build encoder, build decoder. That is terrible. That is absolutely terrible. All right, so let's see here. So let's do a struct a tokenizer, and we have our encoder, which is going to be a hash map. Let's see. What are really good hash maps in Rust? I forgot. Best easy hash map Rust. It's built in. It's built in. Hash map. All right, there we go. Easy. All right, let's do this. Okay. Hash map. This will be a string and an int. Int 32. How do we say? Let's see. No, I32. There we go. And then a decoder. And it's going to be the opposite, right? So we got our encoder and our decoder. Here, let's just say vec. Let me say vec1. All right, done. All right, let's see if we can build this. Run, por favor. Thank you. Hey, there we go. All right. Follow your passion, will become an AI and machine learning engineer. There you go. Hey, let's do it together. Big risk because both med and AI field are very different. They are. What if you combine them together? What if you put them together? You bring all of your medical knowledge with your AI knowledge. You will become the ultimate AI medical engineer. You could do it. Okay. Encoder, decoder. Is there anything else we need? We just need to build the encoder, build the decoder. Right? Between the two? I think that sounds really easy. Yeah, it would be very crazy. It would be. Okay, let's keep going. We're gonna push hard here, guys. We have 3 minutes. We have 3 minutes. Okay. So we need. What I want to do is say implement the tokenizer for. What do we call it? Tokenizer. What would we just say? New? Implement new for tokenizer. We do this. Wait, how? What's a good way to do this? 3 minutes. I know, right? Let's see. Rust simple struct impl example. We're warming up on Rust, you guys. We're gonna just like this. So implement rectangle. Okay, yes, okay. Implement tokenizer, and we're gonna put this in here. We're gonna call this new, and it's going to return a tokenizer. So that's the plan. We're gonna return a tokenizer. I suppose we could say self like this. And then we can say self, and we need 2 hash maps. We need 2 hash maps. Did we do, okay, hash map new, okay. Hash map new, and then hash map new. Like that, okay. Let's see if this builds. Oh, all right. So one expected one. Okay. All right. Let's see. Can we get this? Mute. It will be immutable. Although it doesn't need to be mutable. It doesn't need to be. I'd rather it not be. Let's see if we can make it so it's not. So mute, okay, hash map new. It should just be an empty. Although, don't we need to specify the parameters of the hash map? We say string, comma, int, i32. We gotta do something like that, right? And this will be the opposite. Build. Oh, come on! Why is it not happy with this? Okay, Steven, can you make a Discord mod? Yeah, sure. Yeah, hey, Donut Dude, good to see you. We got 1 minute left. Actually, I gotta go. You're looking very orange. Am I? Wait, really? I feel like I'm ordinary. Duke Kodum. Hey, Duke Kodum, good to see you. Happy Monday. All right, you guys, I do have to go. I've got a meeting starting here, and for the rest of the day, I will be wrapped up. Tomorrow, what we're going to do is we're going to continue what we've started on an adventure. We started on a new adventure. It's a lot of fun. We're going to build ChatGPT in Rust. So what we did last couple of weeks, we did it in Python. We wrote our own transformer, our own decoder layer in Python. We're going to do that in Rust now. We're going to do it in Rust next. So if you want, join the adventure. We're going to do this every single day. Bonzupi, thank you guys. Quick fix. Oh, we have a Trump. I know, right? Exactly. Thank you guys so much for joining in. We'll be back tomorrow. We're going to continue on our Rust adventure, and we're going to make another transformer. LFG Donut Dude, yep. You guys have been asking for it. You're like, hey, we should do more Rust. I'm like, okay. We're going to be building Rust live on stream. Have a beautiful day, everyone. Thank you. Have a good rest of your day, guys. See you tomorrow. Bye, the Basper. See you, Sergio. Donut Dude, Quick Fix. Bonzupi. You guys. Duke Kodum as well. All right, see you guys tomorrow. Bye, everybody. Bye, guys.